was still at least one on the worksheet that was, or at least, I don't know if it was the front side. Anyway, all I want to do today is give you the correct answers to the worksheet, take questions on the ones that you're struggling with, and have you work the backside. Now remember, Friday is our exam. We want to make sure we're comfortable with working both related rates and optimization questions. Okay, and I'm going to pull the ones on the test and come straight off the ones that you've seen. So, let's see here. Robert, what'd you get for number one?
Negative 0.059 centimeters per minute.
I got negative. Would you tell me, did you get an exact value or decimal? Obviously a decimal.
Yeah.
Is that the equivalent of negative 1 over 32 pi?
Yeah.
Okay. Whitney, what'd you get for number two?
Okay, I haven't invested in one, so.
Okay.
Okay, I got negative 0.0159.
Is that negative 1 over 20 pi? Is that what you got? Let's do the conversion here, just to make sure that the decimal equivalents are working. And on a test, I'm okay with the decimal equivalent. I just want to make sure that you're. What did you say you got?
Negative 0.0159.
Yep, negative 0.0159. Ashley, what'd you get for number three? 65 miles an hour. Okay. MJ, how about four?
I didn't quite finish one. What I got is dABC over 10 equals 1 plus dBdt.
Okay. I think it ends up being negative 8/5, negative 1.6 as a decimal. Okay. Alexis, did you get 5? 5 was that the one where the water was going in the tank and out of the tank simultaneously?
Yeah.
Oh, and it was a fairly challenging one. So when you say the worksheet was easier, I don't know if that counts as an easier problem, right? Anybody want to throw out a possible answer on number 5? 3?
Alright, you said throw out a.
Cody, what'd you get?
10,080 pi?
10,080 pi. What is that as a decimal?
I have no idea.
I got
31,667.
I got 800,000 pi over 9. Oh, that was the total change in volume, so I think I got 289,252.6 pumped in. Because the question is, how fast is it being pumped in? We got 289,000 and some odd change, yeah? Is that what you got? Okay. We want to talk about that one, because that one's really not as difficult as it seems when you read it. It's just got one little caveat that you've got to worry about. 6 is the one that we want to make sure we're comfortable with. Okay, 6 is definitely a hard question, right? How did you get 6? Not even close. Try it.
I attempted.
Who's got what they would throw out as a possible answer? Adam?
0.000036.
How many zeros you got there?
4.
For the change in height? Is that what we were looking
Yeah.
for?
Mm-hmm.
I have, if I can read my own writing, 0.00005033. We want to probably talk about that one. That one's trickier than it looks. Carly, what'd you get for 7? Nothing? You didn't do 7? Why not?
Maybe I thought.
How long did it take you to do this? Did you stumble on the 5 and 6 and then stop? Did anybody try 7? Because I don't want to do 7 if you haven't tried it. Only 3 of us, 4 of us, 5 of us tried it. Robert, what'd you get for 7?
I got 0.382 feet per minute.
Is that 6 divided by 5 pi by chance?
Yes.
Yes, it is. 6 divided by 5 pi? Yeah, you guys kept saying this was an easier worksheet. I kind of thought 8 was hard too. How'd you do with 8, Greg?
I got an answer.
What'd you get?
2.809.
2.089?
2 point.
I have 55 divided by 2 squared is 31. I got 4.9. So, I'd say there's at least 3 we ought to have on the board today, if not more. Where shall I start?
5.
5? Water is leaking out of an inverted conical tank at a rate of 10,000 cubic centimeters. Donkey shorts. Hi, David. This is for David.
Oh, okay.
You wanna go take care of that? Water is leaking out of an inverted conical tank at 10,000 cubic centimeters per minute. At the same time, water is being pumped into the tank at a constant rate. So I've got water leaking out and water pumping in, correct? So the change in volume is the sum total of those two things. dVdt is how fast it's being pumped in minus how fast it's being pumped or drained out. Are we okay with that? So, the tank has a height of 6 meters. And a diameter of 4, so we'll call the radius 2. If the water level is rising at 20 centimeters per minute, Jordan, what is that, 20 centimeters per minute?
That's rate.
In this particular problem though, the rate of what?
Rate at which the water is flowing, or is rising.
So we're gonna call this H and this R, and it's giving me dHdt, that's what I want you to identify. When they tell me that the water level is rising at 20 centimeters per minute, I'm gonna write that down, 20 centimeters per minute. You guys see a problem with this? What is it?
The 6 is in
Yeah, this is in meters, and this is in meters, and this is in centimeters. What's the volume? How fast is it? In the change in volume, or the rate at which it's being leaking out, is 10,000 cubic centimeters. So I've got this thing in 2 different units of measure. I've got to get it all in terms of centimeters. Don't you agree? So 6 meters is 600 centimeters. Were you guys able to pick up on the fact that you had 2 different units of measure? I probably would not do that to you on a test, but it's good that you see that sometimes they'll do that. On an AP test, that's something that they actually might do. What else do we know? We want to find how fast the water is being pumped into the tank when H is 2. So here's the problem. It tells me that the change in volume is leaking out at 10,000 cubic centimeters per minute. And we don't know how fast it's being pumped in. So is it okay to say that the total change in volume, dVdt, is how fast it's being pumped in? Minus how fast it's leaking out? So if I want to know how fast it's being pumped in, I'm going to find dVdt and then just add 10,000 to it. Okay? So when I think of dVdt, in my mind, I'm going to let that be how fast it's being pumped in. But it's really not. I've got to bring this 10,000 over when I'm all done. So the change in volume, I have to think of how fast it's being pumped in minus how fast it's being pumped out. But because of my notational thing, I want to call dVdt. I want to be able to work with that in terms of the volume of the cone. Are we good with this? So whatever we get for dVdt, what am I going to do with it at the end? I'm going to add 10,000. You guys understand why? Okay, so volume of a cone, just like all the other cones. Now it becomes just like all the rest of the problems. 1/3 pi r squared h. Anywhere to get in terms of the single variable, Sarah?
Do you have similar triangles?
200 is to r. That's 600 is to h. 200h equals 600r. So r will always be 1/3 of h. I got r in terms of h because I have information about dHdt, right? So I'm going to plug this in for r. Volume is 1/3 pi times r squared times h. 1/9 h squared times 1/3, I get volume is 1/27 pi h cubed. We like it. Quincy, take the derivative with respect to time for me, please. This is a v, sorry dear. I'll write so you can read it. dv dt, 1/9 h squared ph. Good. Divide this nonsense out, which is multiplying by 9, so I get 9 dv dt divided by pi h squared equals my dh dt. Oh, I want dv dt, don't I? I lied. It's all set up this way. I don't need to solve for it, because doesn't it tell me dh dt and h? So I'm going to find dv dt. dv dt is equal to 1/9 pi times h. H is what? And what instant were we trying to find it? When h was 200 centimeters? 200 squared times dh dt, which was 20 centimeters. Help me out here. Calculator work here. 200 squared is 4,000 times 20 is 80,000? I'm off by a 0. 800,000 pi over 9. 800,000 pi divided by 9. Is that my answer? Why not? Got to add 10,000 to it because I've got to account for the fact that it's leaking. This is the total change. It counts both being pumped in and leaking out. I just want to know how fast it's being pumped in. So I'm going to add 10,000 to whatever this is a decimal. What did I say it was? 289,000. 252.68 is what I came up with. Are we good at this question? It's really not a whole lot different than just any other volume question, other than the fact that it was being pumped in and leaking out at the same time. So that's what made it a little trickier. If you bumped up against this, okay, would you be okay with it? Okay. What other ones should we do off of that worksheet?
6.
6 is the trough problem, isn't it? Okay, we're going to spend a little extra time on this. Read me the basics, if you would, on the trough problem, Troy.
A water trough is 10 meters long, and the cross section has the shape of an isosceles trapezoid. That is 30 centimeters wide at the bottom and 80 centimeters wide at the top.
30 centimeters across the bottom and 80 centimeters across the top. And how long?
It is 10 meters long.
10 meters. Centimeters, meters, I got a problem already, don't I? So I want to change 10 meters into 10,000 centimeters? 1,000 centimeters. Right? Okay, so now I'm all in centimeters. Good. Go on.
And it says the height is 50 centimeters.
The height of this thing is 50. Do you care if I just draw it in right here? Okay?
And if it is being filled with water at a rate of 0.2 centimeters cubed a minute,
Stop. It's being filled with water at 0.2 cubic centimeters per minute. What is that?
that is the volume.
Is it the volume?
Well, that's
Or is it the change in volume?
it's a change in volume.
So dv dt, you said was 0.2 cubic centimeters per minute?
Mhm.
Okay, we'll make a note of that.
How fast is the water level rising when the water is 30 centimeters deep?
So I need to put my water arbitrarily in here somewhere, right? Here's my water. Okay, like so.